Okay, class, can I have 2 minutes of your time? If you can just look at the blank space on the board. So Alea's question was, how do you do geometry problems? When you see a geometry problem, how do you know how to start? You also want to know the answer. So, how to get rich? Yeah, so there's a couple of questions that you can actually ask yourself. Okay. For example, in circle geometry, a lot of the problems involve the center of the circle. So a good question to ask yourself would be, is there a center of the circle? Okay. Okay, so we'll play with that now, but another good question to ask yourself would be, because a lot of the problems involve cyclic quadrilateral, so another question would be, is there a cyclic quadrilateral? And these are all yes or no questions. If the answer is yes, it means you can do something. If the answer is no, you can skip to the next question. So, Alea, pardon me, but what was the next one?
Is there tangent?
Is there a tangent? Because some of the theorems involve tangents. So I'm strategically creating yes-no questions for myself. And the last question?
Are there parallel lines?
Are there parallel lines? Now, how important are those parallel lines, hey? They've been haunting us since forever. Since grade 8. And then as a last question that you can ask yourself, can I apply basic triangle geometry? Now what that means, for example, is the 3 angles inside a triangle add up to 180. That kind of thing. Okay, so let's just focus on these questions, ladies and gentlemen. And if the question was, is there a center of the circle? You see, I'm getting all fancy here today. Is there a center of the circle? Then there's a couple of things that you could do with that. So firstly, if I have a circle and there's a center, can anyone give me one theorem involving a circle with a center?
The center is 2 times circle. 2 pi r squared.
Okay, so if I have 2 radii, right, and a point on the circumference, if it's there, for example, then the angle at the center is twice the angle at the circumference.
Yeah.
So this angle is double that angle. But just pay attention, because things are changing, okay? So now, let's say now I've got those 2 radii, and please look there, because it's really like a movie. But let's imagine the point on the circumference was here, and you join to that point. Now that is the same theorem, but then this angle is going to be twice this angle there. Okay, sorry, that was a bit bad. But let's say now the point was down here, so then you join to that point like such. And then, but now the only difference is that this angle, so this is involving a reflex angle, is going to be twice that angle. Okay, so can anyone give me another theorem involving the center of a circle?
If the radii bisect a chord, is perpendicular.
Yes, I think what you were trying to say is that the line drawn from the center of the circle, which is perpendicular to a chord, so let's say it's perpendicular, sorry about the kindergartenish drawing, but it's going to then bisect the chord, right? But you can say it the other way around. If the line bisects the chord, then it is perpendicular. Are there any other theorems involving the center of the circle?
Yeah, the midpoint theorem.
The what?
Midpoint theorem.
The midpoint theorem is a triangle theorem, so no. Cool. Now, the next question, folks, would be, is there a cyclic quadrilateral? So what is a cyclic quadrilateral? So you've got the circle, and you see, basically what you're doing is you've got 4 points on the circle. So let's just create any 4 points on the circle. And when we join those 4 points with lines, then, and once again, sorry for the childish drawing, but that is a cyclic quadrilateral. Now, there's a couple of theorems that you can that you can apply to a cyclic quadrilateral. So what can we do with this thing now?
Angles in the.
So this, what can we say about this angle and this angle? Okay, this angle and this angle. What? They equal 180. And what about this angle and this angle?
180.
They equal 180. The opposite angles equal 180. Okay. But now also, let's say now we take one of these lines and we extend. So we take this line, for example, and we just extend it. That creates an exterior angle. That angle is going to be equal to the furthest angle away from it inside. Equal, right? Okay, now also let's say now we take this line here, but we extend it. Okay, you see what I'm doing? I'm extending it. Then that angle is equal to the angle furthest away on the inside. Okay, now I just bear with me now. Okay, now if I take this side here and I extend it, now you can extend it in that direction. Okay, in which case this angle here is going to be equal to the furthest away angle there. As a reason, you would just say exterior angle of cyclic quad, but also that line could also just extend in that direction, and then that exterior angle is going to be equal to this furthest away on the inside. So there's a couple of things that you can do, but also something else is that if I have the diagonals as well, then you have this butterfly theorem, right? So then this angle and this angle would be equal. This angle and this angle would be equal. This angle and this angle would be equal. And this angle and this angle would be equal. What do we say in that case? Angles in the same segment are equal. Equal. There we go. Okay, now the next question, and just pay attention because this will be very useful, I promise you. So the next question is there a tangent? Now that's pretty obvious because you have a circle and then you've got this line on the outside. Okay, that's not a tangent at all. But you've got this line on the outside. There we go, that's better. A tangent. So what can we say about the tangent?
If a line connecting to the center of a radius and creating a nice triangle.
Okay, so if there's a center as well, and this could also go with the fact of is there a center of the circle as well? So this kind of marries these two concepts together. Okay, so if there's a center of the circle and you have a radius, then it is perpendicular. You get that?
Yeah.
What do we say? The tangent is perpendicular to the radius. How do you like that style, right? Okay, so that's one thing you can do, but what else can you do? Well, let's say the center was not given, okay, but they gave you 3 points on the circle. So there's a point there, the point of tangency, and another point. And I connect those points with lines. So what's going to happen in that case is this angle is going to be equal to the furthest angle away on the inside. And this angle is going to be equal to the furthest away on the inside. Do you follow? Okay, don't worry if you didn't get it the first time. Okay, don't ask questions right now. And then, are there parallel lines? Well, you see, folks, if there's parallel lines, you're going to have these parallel markings. Okay, well, that is definitely not parallel. You know, in fact, let me just draw with the lines. There we go. That's better. So let's say we've got parallel lines, and then we have this other line which kind of goes through them. Now, there's various things you can say. For example, this angle is equal to this angle. Alternate angles are equal. This angle is equal to this angle. Co-interior. No, that's a lie. This angle is not equal to this angle. They're supplementary, right? Because they lie inside this U shape here, okay? So they're supplementary. But at the same time, here's a U. So that means that this angle plus this angle is 180. So this and this are called alternate. They lie in the Z shape. You've also got these nice F shapes like here. Let me just take the highlighter, folks, and just there's a nice little F. So the armpits, that armpit and that armpit, they are called corresponding angles. And lastly, can I apply basic triangle geometry? For example, you've got a triangle. Let's say now you know what these two angles are. So then you can say this angle is 180 minus them. So basically the moral of the story is, if you want to be good at geometry, you need to pay attention to these questions here. So is there a center of the circle? Okay, let's see if we can do something with this. So let's say C for center. Is there a cyclic quadrilateral? So let's say C for cyclic. Is there a tangent, T? Are there parallel lines, P for parallel? Can I apply basic triangle geometry? So I'm going to put there I for interior angles. So maybe what you can do as an exercise is take these letters and form a sentence or something. Let's see here, can chickens trip perfect idiots? I don't know, you make up something.
Can chickens fly?
Well, there we go, something like that.